Hello everyone, welcome to session number 28 of the Java programming course. In today's lecture, we will learn how to manage transactions in JDBC using commit and rollback. This session is part of the course R1UC304C and I am Dr. Amit Batra. Let us understand how transactions ensure data consistency in real-world Java applications. Before moving forward, let us quickly review the key concepts from session 27. In the previous lecture, we discussed prepared statement and callable statement, their usage, examples, and advantages over statement. This knowledge is essential because today we will use JDBC statements within transactions. Let us start with a recall question. Can you can you highlight the key differences between prepared statement and callable statement? Prepared statement is mainly used for executing parameterized SQL queries, while callable statement is used to execute stored procedures. Now, here is today's opening question. Can you recall the ACID properties of a database transaction? These properties are fundamental for understanding why commit and rollback are required. At the end of this session, students will be able to understand the use of commit and rollback methods and implement transaction management in JDBC using these methods. In this session, we will cover introduction to ACID properties and their significance, the concept of commit and rollback, think pair share activity, hands-on JDBC implementation, problem-based learning, and finally conclusion and discussion. A commit in a DBMS is a command that makes all changes of a transaction permanent in the database. Once committed, the changes become visible to other users. Commit finalizes a transaction and ensures that the ACID properties are maintained. Let us understand the ACID properties in detail. Atomicity means all operations in a transaction succeed together or fail together. Consistency ensures the database remains valid before and after the transaction. Isolation ensures transactions do not interfere with each other. Durability guarantees that once committed, changes are permanent even after system failure. By default, a JDBC connection operates in auto commit mode, meaning every SQL statement is committed automatically. However, there are three main reasons to disable auto commit: to improve performance, to maintain data integrity, and to handle distributed transactions. Here we see how to disable auto commit mode. Using connection object con.set autocommit false as a parameter, we tell JDBC that transactions will be controlled manually. Now changes will not be saved until we explicitly call commit. Once autocommit is disabled, SQL statements are grouped into a transaction. The commit method saves all changes permanently. The rollback method cancels all changes since the last commit, ensuring atomicity. This is a short interactive activity. Think about how commit and rollback help achieve ACID properties. Discuss your thoughts with a partner and share your understanding with the class. This slide shows a sample JDBC program. First, a connection is obtained and auto-commit is disabled. SQL operations are performed inside a try block. If all operations succeed, the transaction is committed. If an exception occurs, the catch block executes rollback to undo all changes. Finally, the connection is closed to release database resources properly. This structure ensures safe and reliable transaction management. Now let us look at a real-world problem. A fund transfer operation uses two SQL update statements. One deducts money from the sender and the other adds money to the recipient. The issue is that JDBC's default autocommit mode commits each update immediately. If the first update succeeds and the second fails, the database becomes inconsistent. To solve this problem, we disable autocommit mode. Both update statements are executed as part of a single transaction. If both succeed, we commit. If any fails, we roll back. This approach ensures that either both account balances are updated or neither is updated, maintaining consistency and atomicity. To summarize, managing transactions manually gives more flexibility than auto commit mode. It allows grouping multiple SQL statements into one transaction and deciding whether to commit or roll back based on the application logic. By the end of this session, students have understood commit and rollback, and successfully implemented transaction management in Java code. In the next session, we will learn about result set handling and work on practical exercises. Students are encouraged to reflect on today's learning. Think about how transaction management prevents data inconsistency and improves application reliability. That's that's all for today's lecture on managing transactions in JDBC using commit and rollback. Now we'll be solving a case-based cum scenario-based programming problem. The statement is in front of us. A university fee management system uses JDBC to process student fee payments. We need to solve three subparts. Subpart A, design a JDBC-based solution to handle fee transactions using manual commit control. B part, evaluate the use of rollback in handling payment failures. C part, critically analyze how transaction isolation and consistency can be ensured in concurrent environments. So, university fee management system processes student fee payments that involve multiple database operations such as deducting payment amounts, updating fee status, and generating payment records. To ensure data consistency and reliability, JDBC provides manual transaction control using commit and rollback. Design overview. The fee payment transaction consists of number one, deducting the payment amount from the student's pending balance. Number two, inserting a payment record. Number three, updating the fee status. All operations must succeed together, otherwise, none should be applied. First of all, we will be creating a database in Workbench. As you can see, the name of the database is we are creating is University 1. Then we are using this University 1 database using use statement. Then we are creating a table named students. And within this students table, there are three fields or column. First is student ID. Data type is integer and constraint we have applied is primary key. It means that student ID is unique and it cannot be null. Second column field is name. Data type is variable varchar, that is it can have variable number of characters, maximum 50 characters in the name. Not null constraint specifies that the value of the name cannot be null. Similarly, pending fee, how much pending fee is of a student, and data type is decimal. 10 comma 2 means that after decimal there are two places. The constraint again not null, that is pending fee cannot be null. Then we are creating another table called payments, and it has four fields or columns. First is payment ID, data type is integer, it is a primary key, meaning that payment ID cannot be null, it is unique. Auto increment means it will be incremented automatically as the records are inserted. Second field or column is student ID, data type is integer. Third column is amount, again it is data type is decimal. After decimal place we are having two places. Not null means that value of amount cannot be null. Payment date, data type is date time, and the date on which the payment is done. Not null again specifies that the payment date cannot be null. Then the line number 13, foreign key student ID references student ID. So this statement creates a foreign key constraint that links the student ID column of the payments table to the student ID column of the students table. Now we'll be writing a Java program in IntelliJ IDE. As usual, we have created a project called commit rollback example, and line number one is import java.sql.star. This imports all the required JDBC classes such as connection, prepared statement, driver manager, and SQL exception. Then we are having the line number three, public class main. This class represents the fee payment module of the university management system. Then we are having line number five, public static void main. This is the entry point of the program where execution begins. Line number seven, connection object. Connection class object con is equal to null. The connection object is declared outside the try block so that it can be accessed in both the catch and finally blocks. Then con is line number 9 try block. Con is equal to driver manager dot get connection. This line establishes a connection with the MySQL database named University 1 using JDBC. Line number 14, con dot set auto commit false as a parameter. By default, JDBC runs in auto commit mode. Here, auto commit is disabled so that multiple SQL statements can be grouped into one transaction. Then line number 17, string update fee is equal to, we are having a update query, update students table, set pending fee is equal to pending fee minus question mark where student ID is equal to question mark. Then line number 18, prepare statement PS1 is equal to con dot prepare statement update fee as a parameter. So this SQL statement deducts the paid amount from the student spending fee. Then we are having line number 19 to 21. PS1 dot set int 1 comma 20,000 PS1 dot set int 2 comma 101 PS1 dot execute update. So the payment amount and the student ID are passed as parameters and the update is executed. Then we are having line number 24, string insert payment equal to insert into table payments, let parenthesis student ID comma amount comma payment date values question mark comma now. Then we are having line number 18, prepared statement, line number 25, prepared statement PS2 is equal to con dot prepare statement insert payment as a parameter. This statement inserts a new payment record into the payments table. Then line number 26 to 28, PS2 dot set int 1 comma 101, PS2 dot set int 2 comma 20,000, PS2 dot execute update, line number 28. So the student ID, payment amount, and the current date and time are stored as payment record. Then we are having line number 31, con dot commit, line number 31. Then system.out.println fee payment successful. So if both SQL operations execute successfully, commit is called. This permanently saves all changes made during the transaction. Then we are having the catch block, SQL exception e system.out.println payment failed rolling back. If any SQL error occurs, control moves to the catch block. Then we are having line number 37. If connection object is not equal to null, con.rollback. The rollback method cancels all changes made during the transaction, ensuring that no partial updates remain. Then we are having finally block, line number 42. If con is not equal to null, con.close. This block ensures that the database connection is closed properly, releasing resources. So why transaction management is important here? Because it prevents partial fee deduction, ensures atomicity of the payment, maintains data consistency, handles failures safely using rollback. Either the fee is deducted and the payment is recorded, or neither operation takes place. So this program demonstrates manual transaction control in JDBC using commit and rollback to ensure consistent and reliable fee payment processing. So if we execute this program, first of all, as usual, we have to go to project structure, click on libraries, and you have to give the path of the jar file here, uh, which we have extracted by extracting the GIF file of MySQL database connector J. Then now we are running this program. Build process starts, and output is showing payment failed rolling back. So why this message is being displayed? Because the student ID 101 does not exist in students table. The update statement fails because the where student ID is equal to 101 matches no rows. Even though execute update may return 0 rows, some JDBC drivers can throw exceptions if constraints exist or updates fail. So foreign key constraint violation on payments table. If there is no student with student ID is equal to 101 in students table, the foreign key constraint prevents inserting a payment. This throws a SQL exception triggering rollback. Other possibilities can be database connection failed or wrong table name or column name or permissions, data type mismatch. So if we check this workbench and execute this query, so execute this select query, execute this select query, we can see we can see uh, the table is empty. So if this returns empty, then the update statement technically does nothing, and the subsequent insert violates the foreign key constraint. So this explains why the catch block executes and you see payment failed rolling back as the output in our Java program. As you can see, payment failed rolling back. So the message payment failed rolling back occurs because a SQL exception was thrown, most likely due to missing student ID 101, causing the transaction to roll back. So how rollback works here? Connection object con.rollback undo any changes that might have occurred in this transaction. In your case, no updates were actually applied, so database remains unchanged. So how to fix this problem? We can fix this problem again going to workbench and let us omit this statement and we can execute this insert query so that the ID 101 is inserted into the students table. Control C. Then you can use here this. So now execute this query. This green ticks are shown showing that the we have successfully executed these queries. Now now we can verify again using the select query. After inserting the record with student ID 101, we can now check again the select query. So now if we execute the select query again, the table will not be empty. We are able to see one record inserted with student ID 101. So now if we run our program again pressing this run button, so you can see here the output is showing as fee payment successful. So auto commit is disabled to group multiple SQL statements into a single transaction. Commit is called only if all operations succeed. Any exception triggers rollback to restore the database to its previous state. Now we have successfully solved sub part A. Now B part is evaluate the use of rollback in handling payment failures. So the rollback method cancels all the changes made during the current transaction. Rollback method restores the database to the last committed state. Rollback method ensures atomicity of transactions. Why rollback is essential in fee payment systems? There can be different scenarios. For instance, one scenario can be payment deduction succeeds but record insertion fails. So without rollback, fee will be deducted and no receipt. With rollback, no changes applied. Second scenario can be of system crash mid-transaction. In this case, without rollback, data may be inconsistent. With rollback, database remains safe. Third scenario can be network failure. Without rollback, there may be partial updates. With rollback, transaction cancelled. So the rollback prevents financial discrepancies. It ensures student fee records remain accurate. It is critical for error recovery and fault tolerance. Now we would like to give the answer to the C part, that is critically analyze how transaction, isolation, and consistency can be ensured in concurrent environments. So when multiple students pay fees simultaneously, concurrent transactions can cause issues such as dirty reads, non-repeatable reads, phantom reads. JDBC allows isolation control using connection object con.set transaction isolation. Connection dot transaction serializable as a parameter. So isolation levels and their impact. There can be four isolation levels. For first isolation level can be read uncommitted. that it means allows dirty reads and it is not suitable. Second isolation level can be read committed and it prevents dirty reads. Suitability is moderate. Third isolation level can be repeatable read. It prevents dirty and non-repeatable reads. It is suitable. Fourth isolation level is serializable that provides full isolation and it is best for financial system. Consistency is ensured by enforcing database constraints like primary key and foreign key. Consistency can also be ensured by validating payment amounts. Consistency can also be ensured by using rollbacks on failures. Consistency is ensured by applying proper isolation levels. So higher isolation levels improve consistency but reduce performance. Serializable is safest but may cause delays under heavy load. A balanced approach using repeatable read or serializable is recommended for fee transactions. So conclusion is in university fee management system, manual commit control ensures reliable fee processing. Rollback method safeguards against partial updates and failures. Transaction isolation and consistency are achieved through proper isolation levels and constraint enforcement. This approach ensures a secure, consistent, and scalable JDBC-based payment system. Manual transaction control using commit and rollback ensures atomic, consistent, and isolated fee transactions in JDBC-based university systems. Thank you for watching this lecture. Keep practicing and see you in the next lecture. Please like, share, and subscribe for more Java programming tutorials.